All right. So I want to welcome everyone. This is the Cleveland Developer Group. It's our virtual lunch and learn for September 10th. I'm really excited that today we're going to have Uriel Gutierrez and Krystian Charubin talking about dynamic web components. They're bringing us their presentation from Midwest Dreaming. It sounds like they've added some stuff to it, so I'm really excited about that. Let's see if I can get this to go to my next slide. Here we go. As always, thank you for joining us. If this is your first event with us, we're glad to have you. If you're returning, that is awesome. We love seeing our group grow, and we welcome anyone across the ecosystem when we have our virtual events, obviously in person. If you're in Cleveland, come check us out. Join us. If you're not, we have virtual stuff too. So we do both. I'm Linda Kane. I'm the leader of this group. Been hosting this group since 2016, so it's been a while. I've been in the ecosystem now for 17 years and hold plenty of certs. Currently work as a developer for Cerity Partners. Always welcome to connect on LinkedIn or through the Trailblazer community. As a reminder, we are running our own little Agent Blazer Champion Status Challenge. So if you are local to the Cleveland area and you've reached your champion status, please let me know. I do have little swag bags for the first 10 people who reach that status that I can share with you. We just have to arrange to get them to you. Local only, I'm not mailing these out because, not always fun to deal with the post office when you're sending things like pins. Some upcoming local events. Every Saturday this month, we're having our Cleveland Salesforce Saturday at the Common Grounds Coffee Shop on Lorraine and the Cam's Corner area. There's plenty of parking behind the building or across the street. There is a shopping center parking lot. The Cleveland Marketer Group actually is kicking off today, and I think it was like an hour ago. They kicked off a series on Marketing Cloud onto the Next Frontier. It's a virtual series, and it goes through the month of October. Lots of sessions, lots of interesting speakers they're bringing in for that. And then our local Whitman and Tech Group is hosting an in-person event on the 17th in Independence. So if you're able to join any of those, you are always welcome to do so, and maybe I'll see you at some of them. So without further ado, I'm going to stop sharing my screen so Uriel and Krystian can take over.
All right, thanks, Linda. Krystian, can you start sharing, please?
Yep.
And while he's sharing, we'll with a lot of sharing. There we go.
The infinite loop of sharing.
There we go. Great. Alrighty. Well, thanks everyone for joining us again. Thank you, Linda, for asking us at Midwest Dreaming to give this presentation over again. We had a great time in Midwest Dreaming with this presentation. So just really cool to be able to, as Linda mentioned, Krystian enhanced it a bit. So it's cool to be able to share what we showed already and even more so. Next slide, please, Krystian. I am Uriel Gutierrez. I am a senior lead developer at Soliant Consulting based out of Chicago. I've been in the Salesforce space for about 10 years now. I actually started my Salesforce career with Soliant as an associate developer and have worked my way up. I do have 10 Salesforce certifications. Not sure if those really mean anything these days, but I have them. That's all that matters. Krystian?
Yeah, hey, I'm Krystian Charubin. I'm the lead technical architect and the Salesforce practice director at Soliant. I've been doing Salesforce for over a decade. I just had my 10-year anniversary at Soliant. I, on the other hand, only have one certification.
You see the title differences, right? Where the certifications matter, apparently.
But yeah, let's dig in.
A little bit about us before we dive in. So as I mentioned, we are Soliant Consulting. We're a registered partner with Salesforce since 2009, and we specialize in Experience Cloud, Nonprofit Cloud, Sales and Service Cloud, and third-party integrations, which are really our bread and butter. All right, so at Midwest Streaming, I like to get the lay of the land. A little hard to do that here with not seeing people or raising their hands, but I'm going to assume someone is either new to dynamic components, has used dynamic components, or are professionals with dynamic components. That should cover all three categories here. So either way, if you guys know what they are, great, bear with us. Let me just get into this a bit. So what are dynamic components? So they're just UI elements rendered at a runtime based on logic or data. Unlike static components, they're not hard-coded in templates, right? So you have that boilerplate code that you create to really show the UI of a component. These are not hard-coded in that fashion. The nice part about this, they provide flexibility, customization, and scalability for Salesforce UIs. And with all this, it allows for more programmatic approach to defining the UI on your template.
Yeah, so we're going to go through evolution of dynamic components in Salesforce, and I think most people were likely introduced to dynamic components with Aura, but turns out dynamic components really existed before, right? They were actually available in the good old days of Visualforce around 2010 or so. You might still remember that Visualforce sort of required you to create a controller to your page to do anything useful, really. So in the case of dynamic components, we had to create a getter that would sort of like assemble our component server side and then bind it to the UI using the component value attribute on the Apex dynamic component tag. Again, in our controller, we have to define the getter that builds the component. Here you can see that we have the get dynamic component function. It utilizes the component namespace to initialize an Apex input text component. We're able to set any needed attributes, same way we would do in the UI. So in this case, we set the label and the value for this text input, but we've had a pick list. We would need to provide pick list options as another attribute, for example. Taking a quick look at our UI here, we can see that we have a very small dynamic form, which is rendering out the input text component. We can see that our default value of Midwest Streamer is there, but the label of the name appears to be missing. So it looks like Salesforce has some work to do.
Yeah, hopefully no one else is using Visualforce these days.
Yeah, so we could go further and create more inputs, specify the rendered tags for dynamic visibility, or even nest multiple components together. But let's fast forward to something newer and see how this was done in Aura, which, again, most of us are probably more familiar with.
Yeah, so as Krystian mentioned, right, dynamic components is probably more known starting off with Aura, even though Visualforce did have its own type of dynamic component, right? But in Aura, the way to build a dynamic component is, well, you would have your template, right? So we have our example here. We have an Aura attribute. We're just calling it CMP, short for component, and it's of type Aura component. What we're doing here is just really whatever's in CMP, we're outputting it out to the UI using the $v.cmp value at the bottom there. And the way this is being tied together in our example is we have our handler function at the top, the init function, which runs whenever a component is loaded on. So if we look at the JavaScript controller, this is the function that's actually going to be running when the component gets loaded, right? So we have our doInit, and within here, you'll notice now we're starting to build out the dynamic component, right? And the way we're doing that is using the $A namespace. That namespace has a create component function that takes in the type of component you want to render and any attributes that you want to provide for that component, right? So to start off with, we want to render a lightning input component, and we're passing in the attribute similar to Visualforce, right? We're passing in the label of name and the value of Midwest Streamer. And then we have a callback function. Once the component is successfully mounted, we set our v.cmp variable attribute that we saw on the previous slide to the instance of that new component. So with this, now if we look at the UI, we have something similar to Visualforce. We have our input type of text with our default value of Midwest Streamer, but this time we actually get a name being the label, right? So the Aura still seems to be working, which is awesome.
Yeah, Aura for the win.
Aura for the win.
And then LWC came out and Salesforce left us hanging. There are no dynamic components in sight. Yeah.
And then we waited a little bit longer.
Yeah.
And then this is what we actually look like now. If you're seeing me with like a nice haircut or anything, it's some AI stuff behind the scenes. But about 5 years later, I believe it was the spring 24 release, dynamic components finally made its way to LWC.
Yeah, so here we can see that, like, dynamic components have been around the block for a while, and Salesforce continued to improve them over the years. We went from having to build them, server side with Apex, to being able to do some much more flexible JavaScript environment of Aura, right? But again, Lightning components were released, and we sort of have more flexibility still and more functionality. So if you've ever built an LWC component, you're likely familiar with the meta file. Here you can see that we have this expose flag, which sort of specifies whether a component is available in the builder. Along with that, we also have targets, which allows us to specify which context the component is available in. So we can make a component available on the home page, record page, experience cloud, a utility bar, and many other contexts. Each target also allows us to specify different configuration parameters. But what we're really after here is the capabilities section. So capabilities is something that components can do rather than a target, which specifies where it can be used. With the introduction of dynamic components, Salesforce introduced the dynamic component capability, and this basically allows our component to instantiate other components at runtime. The other piece to this equation is sort of like the syntax and the components they made available. So here we can see that we have the LWC component tag, which serves as a placeholder in the DOM where the dynamic component should be rendered. The LWC is directive provides an imported constructor at runtime to the LWC component element. It accepts an expression that resolves to a Lightning element constructor. And again, you can also pass in any needed attributes, like, if this were rendering a Lightning input, right, we could provide a name, a label, and other properties sort of manually. But again, there's a little bit more interesting functionality that Salesforce give us, right? So while a WC spread is not necessarily specific to just dynamic components, it helps us a lot. So in certain cases, it might not be possible to set all the potential properties a dynamic component can accept via the standard markup syntax. So for example, when a component to be instantiated is known in advance, or the components to be instantiated accept a different set of public properties. In those specific use cases, a LW spread directive can be used to dynamically set the dynamic component properties at runtime. The controller, we would simply need to create an object with all the needed key value pairs and simply just bind it to our component using the LWC spread. But again, enough with the slides. We all know that you guys came here to see some code in action. So for the remainder of the session, we'll work through some examples of creating a static contact creation form, which will require either a billing or shipping address, into something more dynamic that we can, in the future, make configurable by the end users.
Yeah, so while Krystian is getting VS Code up, just piggybacking off of what he said. So our example here is something very simple, right? Just for demo purposes. But we have a form, a new contact form that's going to provide a drop down for shipping and billing. Krystian, can you zoom in maybe one more time? And then we have some inputs for first name, last name, and some address inputs. So to start off with, like, how would we build this out, without dynamic components? Well, it's a lot of code, right? It's boilerplate code. You have to go in and build out all the inputs. So you'll see here at the top, we have our combo box for our billing and shipping address. We have some inputs at the another combo box for salutation, a couple of inputs for first name and last name, and then we have 2 shipping Lightning input address fields for shipping address and billing address. So what if we don't want to show both of these at the same time, right? Well, with the normal LWC, we have getters, and we use those to really decide the visibility of the components. So you'll see Krystian here highlighting the LWC if the show shipping, and we also have another one for LWC if for show billing. So if we look at our JavaScript file, we're really just setting up a little bit more configuration, right? We're defaulting the type value to shipping. We have our options for our salutation. We have our type options, which is the billing and shipping address. We have a little on-change handler that sets the type value to whatever type option was selected by the user. And here we have our two getters, right? So we have the show shipping that's going to run during when the component first loads, and then show billing as well. And dependent on what type value is selected to be, the appropriate getter will return true and then thus display the correct Lightning input address field to the UI. So
yeah, but you can imagine that, like, if you have a much more complicated form, right? If you're trying to do dynamic visibility, you're gonna sort of get into getter hell, right? Because you'll need to define a ton of headers for whether you want to display or hide different elements of the form.
Yeah, so this is just like a simple, example. But as Krystian mentioned, imagine you had a much more complicated form, right? You're gonna have to create many different layers of getters just to accomplish your goal here. So in this use case, let's take a look and see what it actually looks like. Bear with us. Cool. So we have our example here. We have our new contact form. You'll see our type is defaulted to shipping as we did it in our JavaScript file. We have our salutation, first name, last name. And then because shipping is selected, we see the shipping address. Great. Krystian, can you change it to be the billing address? Great. Now we have our billing address. So great. Well, again, this technically will work, and it's a very simple use case. It will meet the needs. If this form ever expands, we're going to run into some issues with more getters and just more tedious work behind the scenes, right? So usually when I run into something like this, I usually try to say, Krystian, there has to be a better way to handle this stuff, right? And then I just let Krystian figure it out, then I implement. So Krystian, how do I figure this out?
Well, so if you use your Google Full Skills, you might see one recommendation to sort of try to loop over the different inputs that you have, right? So in our next example here, we can see that we still sort of start off with our combo box for the types and salutations, right? But when we get to the name field, instead of rendering out first and last name or defining your first name and last name directly, we actually have a list of name fields that we want to specify, right? So we have a little loop here. So we iterate over each name field, and we bind it to the line input, right? Passing in the configure label and configure type. And then again, but like not everything is a Lightning input, right? So we actually have to define a second loop for address fields, right? So here, we have a list of addresses. We loop over them, and here we, type out or bind all the different properties of addresses, right? So this sort of got us part of the way to being dynamic, right? But this really only works if our like fields are sort of next to each other, right? Because if we had sort of like first name address, last name address, this wouldn't really work well for us. But anyway, so with this, you can see that in the controller, we're still defaulting our value to shipping. We have our type options, our salutations, but here we can see that now we're sort of specifying those lists of inputs that we want to render, right? So these are the name field. Here we're just binding the labels and the types, and similarly with addresses. We have a little change handler, right? So whenever our type changes, right now we're just sort of printing out which type we're trying to render. But one of the issues that we're going to run into is sort of in terms of visibility, right? Getters are sort of not smart enough to have enough context into which iteration in the loop you are. So when we're trying to render the billing or shipping address, right, that getter can't return dynamic value based on what was selected, right? Because it doesn't know which iteration we're in. So if we look at our next loop example here, we can see that we have our type that's default to shipping, but it's really rendering both, right? Because the getter wouldn't be smart enough to know, hey, I'm looping over shipping and I actually want to display shipping versus hiding billing. So this is again sort of where dynamic components can sort of help us.
Yeah. So now, we saw that our code is still, we still have quite a bit of code on both the template and the JavaScript side, which is fine. But let's start introducing, dynamic components to really do some of the work for us here.
Yeah, because you can see that, like, the form's starting to become a little bit more configurable, right? Because, well, this is just, the JavaScript objects, right? Like, this configuration can come from other places, like custom metadata and such, right? But again, we have to sort of like define, or the structure is not super conducive, right? Because you'd have to have multiple lists of fields they want to define. So a step to take this, one step to take this further is again to use dynamic component. So if you look at our form dynamic implementation here, we can see that the template is much smaller, right? Rather than sort of defining all the fields explicitly, now we're just looping over all the inputs, right? And then we're just using the LWC component tag with the corresponding LWC is operator, which again passes in the constructor, an LWC spread operator that applies all the different attributes. So again, in the previous example with the loops, right, we need to have multiple lists because we're trying to apply different properties to line input versus address input. If we look at our controller here, we can see that we start by actually importing all the constructors statically at the top of our component. And then again, rather than having those specific lists of inputs sort of per type, we just have one list of all the inputs. And here we're able to specify which component this input will be. So again, the first one is the combo box for the shipping type. We can pass in all the necessary attributes. So again, we're passing label type, default value of shipping, the different options for that address type. We do a similar thing with salutation against a combo box with its corresponding options. And then we sort of go on to create, the input text or Lightning input components for first name, last name, and then those address inputs for shipping and billing address. So if we go to our example here, again, we can see that form looks pretty much exactly the same, but our template shrunk a lot, right? Because everything sort of ended up just being configuration that, again, can sort of just be defined more programmatically through custom data or other means.
Yeah. So Krystian, one of the issues I'm already noticing though is I still see both my shipping and billing address, even if it change, right? So, so as Krystian mentioned, right, we are able to shrink our code on our template way down, right? And yeah, some of our JavaScript got bigger, but it's more configuration at this point. So Krystian, if we go to back to VS Code, well, let's go ahead and fix, the visibility issue now, right? So nothing really special about this. It's just regular JavaScript that we're going to be writing now, but within the LWC component tag, right? So to handle the visibility, we're just checking to see if one of the properties on the input is set, right? If it's not, then we're going to hide the component from the UI. Otherwise, it'll be shown. But everything else still stays the same. We're still looping through our inputs and calling that LWC component tag with the input and the attributes being passed in. So if we go back to our JavaScript, we're still taking in statically importing the inputs we're going to be working with. We're still setting type value to shipping by default. And now we have our inputs, and we're actually populating this within our connected callback instead of building it outside. And when we're building this, we're creating our combo box with our attributes, but now we're actually binding the onChange handler to the component instance, right? So that way, when we're changing the value on the UI, the function will still run. So everything's still going to keep working. We still have our combo boxes and the inputs that Krystian mentioned, and then our address inputs as well. And then at the end of our connected callback, we're just calling a handle type change, and we're passing in the type value that we set on the UI. That type change is going to call into a function at the bottom there, which really just helps us decide which address input component to show based on what was selected. And this is again the is hidden field that we're setting on the LWC component. This is where we're setting the value to decide whether or not to render it.
Yeah, and the reason that we're calling handle type change interconnected callback is sort of just so that the default value gets properly handled, right? Because by default we say, the value should be shipping, right? But the form by default, like all the inputs are visible, so we call this so that way the visibility creator gets recalculated before it renders. And then for any future changes, that gets done through the handle change on change callback on the type field, which again just calls our dynamic visibility function here.
Yep. So, Krystian, can we see this component in action?
Heck yeah.
Let's see. So still the same thing, right? We have our type defaulted to shipping. We still have our salutation and our text inputs, but now we only see the shipping address, right? So if we switch shipping to billing, we should see the billing address. Great. So we solved our visibility issue just with simple JavaScript, but still within the LWC component, the dynamic component tag, right? So the dynamic component tag is really taking in our configuration from JavaScript and rendering it out to the UI. And I think Krystian mentioned this a little while ago. The nice thing about this is if you really want to make it, configurable, right? You could build all this like in custom metadata, for example, bring that metadata into the controller or into the component and really let that metadata drive your UI and the configuration behind the scenes. So very powerful.
So rather than hard coding all of these things here, right, you can again just programmatically build it up based on custom metadata or layouts, field sets, and whatnot.
Yeah, so very powerful stuff. Again, simple example for our use case, and we know you guys aren't here for the simple example, so put our heads together and came up with some pretty neat use cases to actually use dynamic components that you might actually use in your I guess everyday work, whatever the phrase is, that you might actually use yourself.
Yeah. So again, one of the use cases that we came up with is when it comes to building models, right? If you look at the Salesforce documentations, generally they recommend to sort of like build a model instance for everything they want to open up in a model. And from my perspective, that ends up sort of building a lot of boilerplate code. You'll end up with like 20 different model implementations, and most of them they basically did the same thing, right? You're just like using a model to sort of house something else. So rather than sort of like rebuilding the model, right? Why not just build a dynamic model container that's able to render anything for you, right? And that's exactly what we did. So if you look at our template here, you can see that's very, very simple, just 5 lines of code. So we'd start off by defining the Lightning model body. We check if we have our constructor available, right? So we can render our component. We're using the LWC component tag. Again, the LWC is a directive to pass in the constructor and LWC spread to pass in any necessary attributes. The controller is just as simple. One thing you'll notice that, again, instead of importing a Lightning element, you're actually importing Lightning model. And then again, we extend Lightning model rather than Lightning element. We have some variables here. So we have a way to pass in which component we're trying to render and any necessary attributes that we want to pass in. For now, we're just going to assign our attributes to the spread attributes variable. I'll explain this section a little bit later. And then instead of doing the static import on top, right, because within the model, right, we don't know what component we're going to be rendering ahead of time. We actually have to do a dynamic import. So this component variable actually just is a string that says, like C/component name or, Lightning /input. And it uses this import function to dynamically grab the constructor, right? And here we pull out the default constructor and we assign it to our CTOR variable. So let's actually see how we can use this. If we open up our form model example, here we're going to have 3 buttons. One that is going to open up our form for creating contact, and then a couple other examples here. So starting off with the create contact, we can see that in our constructor we import our custom modal component. So that just becomes our modal variable. And again, in that button, right, we have the handle create contact handler, and then here we simply just call model open, and we tell it which form we want, which component we want to render. So let's first start just rendering our old static form.
Mm-hmm.
Then again, we just use that back and passing in the component attributes with the component reference of cform. And that one that didn't have any input attributes. So if we refresh this, go create contact, you can see that we have our form, right? We can switch shipping and billing.
Yeah, so this is rendering, the very first form that we spoke about, right, where it's all the HTML code, all the inputs are added to the HTML itself. So now if Krystian is updating it to run, let's run one of the dynamic component forms that we have here. So form dynamic visibility here, and hopefully Salesforce saves. Krystian, how good's your internet? Oh, it looks like it's pretty good. All right, let's.
So if you go back in here and open up the form again, this time we passed in the attribute of billing, right? So our type defaults to billing, and again, we can still switch it over to shipping because the dynamic form has that visibility function implemented.
Mm-hmm.
But again, there's other things that we can open within using our model, right? So one example that I wanted to show is actually opening up just a lightning slider, right? The neat thing about this is, with input components, you generally have like the onChange function that gets called whenever the value changes, right? So our onChange is connected to this handle change function here, right? This basically just like prints out the details of that event. So it's going to print out our new value. So let me open up the dev console real quick here. So if we open up our slider, we can see that's just like the most basic one, 0 to 100. And as we slide this around, we can see that our handle change function is being called, and it's printing out the the current value of the slider. And this is neat, right? Because we can inside of our model opener, right, inside of the attributes, we're able to pass in static attributes like billing for that form, right? But we can also bind it to functions, right? So we can react to changes in our components. So one of the things you might want to do is actually maybe open up a flow in a model, right? So that's our next example, and you might think that generally you would use the Lightning flow element to embed a model in an LWC component. But if you try to do that with dynamic components, you find that doesn't quite work. When we're calling the import function, right, it doesn't actually resolve to a constructor. So if you spend some time digging around the source code, you'll see that Salesforce internally actually uses this interrupt flow component that does all the heavy lifting. And behind the scenes, it sort of just masquerades itself as a Lightning flow component. But anyways, in here, we're going to say we're going to open up a flow, and then we sort of pass in all the different attributes, right? So we have to specify which flow we want to render. So here we're going to render a screen flow that's called screen flow. We define behavior to just none because by default it will keep just restarting. And again, can bind function handlers to it, right? So for example, we might want to recognize that the flow finished running, and if so, close the modal, right? So it doesn't remain open. So we have our on status change here, same as we did with on change on our slider. So if we click on our button, we can see that we're inside the screen flow. We hit finish, and then nothing happens. Our change handler didn't get called. So what gives? This is sort of where the extra piece of code that I was showing you guys before in the modal is for. Normally, when you're doing custom events in Salesforce, you have to sort of like dispatch a new custom event. So in that Lightning slider element, it dispatches a change custom event, right? So then that becomes accessible to us using the onChange attribute, right? And we're able to pass the handler function to run whenever the value changes. Again, flow is a little bit different, a little bit broken, and it does actually submit the normal change events. So after some digging, I figured out that rather than depending on the standard change events, I can sort of forcefully register event listeners. So here, instead of just taking those attributes directly and applying them to the component using a WC spread, I sort of pre-process the list of the object of attributes, and I figure out if any of the attributes start with on, right? So it's like on change, on status change, and if so, I forcefully sort of register them to the dynamic component I'm trying to render, right? And otherwise, I sort of just leave the WC spread to apply to the component.
Yeah, this is all the new stuff that Krystian added, so I'm really learning with you guys today as well.
Yep. So if we change that and refresh, you can see we open our modal, and we're already seeing our change handler running, right? And this is saying that the flow started. It's the flow is screen flow. If we click finish, we're going to get another change handler to signify that the flow finished running. But again, our modal didn't close just yet. So normally when it comes to closing modals, you can only close them sort of like within the modal, right? So you would have to call this.close. But when we're in our form implementation, we don't really have access to the modal. So to solve that, I end up, when I add the event listener, instead of just passing the event back to our handler function, I also pass in a reference to the modal into that change handler. So in our controller here, we can see that in our change handler we have the event itself, and we're being passed in a reference to the modal. So I can check if my event detail status is finished, right? So again, this signifies that the flow finished running, and if so, I can force close the modal. So if we save this real quick. And we refresh. Again, we're getting our change handlers here for the flow starting. We're getting one for finished, but again, most importantly, that reference got passed through, and we're able to automatically close our modal once the flow finished running. So again, this is pretty neat. We sort of also showcased how Salesforce is somewhat broken because they're not consistent with their implementations.
Salesforce consistent? I don't think I've ever heard of them being consistent. So Krystian showed some awesome stuff, how to use dynamic components in a modal, right? So using that same modal container over and over again, which is pretty cool. You don't have to create a different container for each modal that you want to now open up, right? So one other thing we wanted to show you is, again, I wish I could ask for a show of hands, but either way, not sure how many people actually utilize the utility bar. The utility bar, in our opinion, is very underused or not utilized very well. So we also built a way to show the dynamic components within a utility bar itself. So Krystian, can you show us that?
Of course.
Let's see here.
So, yeah, like Uriel was mentioning, like utility bars tend to be somewhat underutilized. So we showed a way to dynamically render any component in the modal. Why not do the same inside of the utility bar? So generally, if you want to show something utility bar, right, you have to make your component exposed. You have to specify the right target, right? Make the component available to utility bar. We expose some properties here to sort of be able to configure what we want to render. So in this case, again, we're going to be able to pass in the component reference and any attributes if you want. And again, most importantly, we have to tell it that this component will be able to render dynamic components using this new capability. So imagine if you had, like a component that you built that you wanted to expose in the utility bar, right? You'd have to go into the metadata file and sort of add in all these targets, necessary configurations to make them available. But what if you're trying to render a managed component in the utility bar, right? You can go in and update the meta file, right? Because it's a managed component. So you'll end up creating a lot of wrapper components, right? And again, you're just creating a lot of noise in your org, right? By just having all those wrapper components. So this is sort of where this container component can help us, because it's able to render anything that we want. We just have to pass in a piece of configuration without writing any code. The implementation of this becomes even simpler. Instead of 5 lines, it's only 3 lines now. We have our LWC component. Again, we're passing in, or we're checking whether the constructor is available, and if so, we pass it on using LWC is. We have any of our additional attributes applied using the LWC spread operator. In our controller, we're no longer getting the modal light because now we're just trying to render an element. We have our inputs for components and attributes. In the connected callback, we dynamically imported the component that we're trying to render, because again, we don't know this ahead of time, so we can do a static import. We assign our constructor, and here, instead of taking the attributes directly, we actually have to parse them, because in the utility builder, we sort of have that, it's a text input, so I have to sort of define our JSON configuration as text, and then this just parses it and just applies it using LWC spread. So if we go back to Salesforce, here we're on the Lightning Sales app, right? Utility items configuration, and here we're creating a new create contact utility, right? We can give a label, icon. But again, most importantly, we can see that here we have our custom properties that we define, right, for component and for attributes. So here we're telling it that we want to render our C form dynamic visibility component. We're also passing in a type value attribute. So again, this is specifying what the default type that is selected, right? Either billing or shipping. So if you go back to enterprise, you can see that we have our create contact utility in the utility bar. And if you click on this, it pops up on our form. The default values, again, defaulted to billing because that's what we defined. But we can, again, switch it to shipping, and all that works the same. And again, there's basically no code that we had to write. We just had to go to our app builder and sort of just reconfigure the utility container to render something.
Really just telling the dynamic component what to render from the builder itself. So yeah, so these are just some use cases that we've run into that we've used dynamic components for. I know Krystian and I have been talking about something a little bit more advanced, like a router, for example, to use for that we could use with dynamic components. We haven't gotten around to it yet. I'm sure we will, maybe for next Midwest streaming or the next user group that we present at. Yeah, super cool examples that we came up with and used. And Krystian, anything else that you have to share?
Nope, I think that's all we've got. I think there's some QR codes for resources.
Yeah, if you guys need any of the info that we use, this is really where we get most of our information from, along with Krystian reviewing source code. I don't do all that. I leave all that for Krystian to do.
Yeah, make sure you turn on debug mode on Salesforce so it's not minimized. It's a lot easier to read.
But yeah, that was our presentation. We appreciate all you guys coming out so we could share this knowledge with you, and we hope you guys got something useful out of it. Well.
So thank you. I love the new examples. I'm really excited, and I'm like, now if I can just figure out how to use the utility bar with Flow.
Oh, Krystian can help you with that.
Well, funny enough, I already did that as well. It was part of a different presentation. So normally there is a Flow component that you can add to the utility bar. So that's available out of the box.
Yeah, I've got a few of those, but I'm kind of thinking, this is
like one of the limitations that I saw with the standard Flow component in the utility bar is that the flows are not aware of the record that you're on. So you can sort of open up a flow, but it has really no context. So I end up building a utility bar version of the Flow component, a custom one that actually is able to pass in the current record into it. So your flow can be a little more smart.
Krystian, your browser doesn't look very smart right now.
Oh yeah, browser is super stuck right now. Yeah. But anyway, so like in the normal flow component, right, you can sort of have a drop down to select what flow you want to run. So I've basically replicated all of that with my flow runner component. And this was not part of the demo, so.
That's okay.
There we go.
But yeah, here, yeah, just using the Lightning Flow component, right? We pass in the flow name, any input variables. This was just a little printout so I could see all the variables that I was trying to pass in. But the main thing we'll see is that we mark it exposed, it's targeting the utility bar. We tell it that there's a flow name attribute, right? So this, again, let's specify which flow we want to render. We also give it a custom data source. So again, normally, all the inputs are just text, right? You can make them bit lists. And then if you want to have like dynamic bit lists, you have to use some Apex to build out that data source. So if you look at that real quick, here you can see that this is sort of implementing the visual editor dynamic bit list component namespace. And here we have the get values function. So this basically just queries for flow definition view. We're trying to just grab process type equals flow. This really means only grab screen flows, only active ones, and then we just add them to a list of dynamic bit list rows. So that way, when we're trying to configure, we have a nice little drop down where you can just like select any existing flow rather than having to like remember what the different API names are. Yeah, so the other piece of this in the controller, again, we're able to pass in the flow name, but we also have a wire, right, for the current page. So from that wire, I'm able to extract the current record ID from the page reference. And if I have a record ID, I will sort of add that into the input variables, right? So flows generally will, if your flow has the record ID input variable defined, we'll be able to just like pass through the current record ID to your flow. And again, this has just other bits of launching flows. But again, this is just an interesting use case that I came up with for another session that we gave at Texadream to just sort of, make the utility bar a bit more powerful. I wish my browser didn't die so I could show this.
It's all right. Yeah, I think we'll just consider your browser dead, Krystian. It's all right.
Yeah, I think so.
Looks like Priyanka's asking if we could share the recording. Linda, I'm assuming you're going to share that out, right?
Yeah. It'll probably be this evening, but I will also send out an email to all the attendees who made it and those who didn't with the link.
Great.
They'll have it.
Awesome. Sounds good. If you have anything else for us, we're happy to answer. Otherwise, thanks for having us, Linda.
This is great. I'm really excited. Now I need to talk my boss into letting me rework some stuff.
That's always the fun part, right?
Oh, yeah. But yeah, I'm actually going to turn off the recording since there don't seem to be any real questions at this point.